Which of course brings us to the concept of the atom. The atom is the smallest element, or the smallest particle of matter that we can interact with. You probably know that atoms are made of smaller pieces, smaller bits of mass, but we cannot really interact with those on the same way that we can with atoms. Somebody could pour a pile of atoms into your hand, and you could hold it. Some of the smaller parts of atoms, which we're about to label right here, if somebody were to pour some, let's say, protons into the palm of your hand, they would not behave the way that regular matter does. So the atom is the smallest thing that we can say behaves like regular matter that we can interact with on a daily basis. So, while we're on the topic of these particles, we may as well talk about them in a little more detail. Atoms are made of what we call subatomic particles. Sub meaning less or below, and that word atom in there. So it's even smaller than atoms. But there's particles like protons, which have a positive charge. Neutrons, which have a a neutral charge or a zero charge. And then we have electrons, which have a negative charge. And these are going to cause the interactions between atoms that make up all the stuff, all the mass that we can actually touch and interact with on a daily basis. So these things are too small for us to interact with, but they do make up atoms that the atoms themselves behave like mass. So let's look a little bit at each of the particles in turn. So protons. Protons, like I said, have a positive charge. Now, I'm not going to go into that in detail too much, but that means they have forces. I should say they just have a certain kind of force that causes them to be attracted to other particles. They exist in the nucleus of atoms, and if you know anything about cells from biology, the nucleus is in the middle. With atoms, the nucleus is where pretty much all of the mass of the atom is. In fact, this right here, over on the upper right, is what you might say, a nucleus of an atom might look like. We've never seen one because they're too small to see, but we can pretty much predict that they look kind of like this. So this nucleus right here of this atom has 1, 2, 3 protons in it. And in fact, any atom with 3 protons is a very specific kind of atom. We call it lithium. Lithium is one of the hundreds of elements that are the basic building blocks of matter. And every atom that has 3 protons is lithium. The number of protons in an atom is what we call the atomic number. That's this right here. All right, and if it has a different number of protons, whether it's 2 or 4 or anything more or less, it no longer becomes lithium and it becomes a different element. So that number is very important. It determines the type of element. For example, hydrogen, the element hydrogen, it's got 1 proton. Helium, it's got 2 protons. We've seen here that lithium has 3. Other atoms like carbon has 6 protons. Oxygen has 8, and so forth. So the number of protons is called the atomic number, and it's always going to be a whole number. If you see these, this box right here, we call this a chemical symbol. It's always going to be a whole number, and that determines the kind of element that is. In fact, as I said before, there are hundreds of other elements. Well, I shouldn't say hundreds, but a little over 100 other elements. And these are all them right here. We call this the periodic table of the elements. And as you can see, if we go to 1, 2 is over here, and then 3, there's lithium. All right, lithium has 3 protons, just like hydrogen has 1 proton. Chromium right here has 24 protons. That's the atomic number right there. What's this? Cadmium has 48. Chlorine has 17, and so forth. So protons are very important to the definition of matter as we know it. By the way, this table looks kind of confusing the way that it's laid out, but it actually makes a lot of sense, and you're going to want to refer to it later on. So each one of these boxes right here, I'm going to call just the objects or the element's chemical symbol, and that includes all the information in each box. So when I refer to that, that means all the information in there. Okay? Moving on in our tour of the subatomic particles that make up atoms, we have electrons. And electrons have a negative charge. You might say they have the opposite force that protons do. We're going to leave it at that for now, but you just think of them as being a minus sign right there. It's the opposite of protons, that force. All right, instead of being in the nucleus, like protons and these other gray ones are, electrons move around the nucleus. You could say in orbits, but they're really not flat orbits. They're actually kind of spherical. So you can think of them as sort of like spherical shells. So in this atom right here, we have two protons in this electrons in this first shell, and we've got the third electron in an outer shell right there. We're going to talk later about how there's a specific number of electrons can exist in each shell, and that's kind of how they arrange themselves. So, if protons are positive, plus, 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 and electrons are negative, minus, 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 in a naturally occurring atom of, in this case, lithium, the total charge is 0 because they all cancel out. So we have protons, 1, 2, 3 protons in lithium, and normally 1, 2, 3 electrons in a lithium, balancing out to 0. Which brings us to our third particle inside the atom, and that is the neutron. Neutrons have no charge, or in fact we say it's a neutral charge. Like in a war, if you're a neutral country, that means you're not on either side. Neutrons have no charge. They do have mass. In fact, they've got very similar to the same mass that protons have. So here's our protons right here, plus, plus, plus. Neutrons are the gray ones. No charge, no charge, no charge, no charge. There's 4 of them right there. And then, of course, our electrons are minus, minus, and minus. So, in this case, we have we've got 3 protons, 1, 2, 3. 1, 2, 3, 4 neutrons, and 1, 2, 3 electrons going around the outside of this nucleus right here. So let's look a little bit closer now at the element, or the symbol of lithium on the periodic table. All right, so lithium has this big number 3 right here, and that means it has 3 protons. It also means, by the way, there we go, that it has normally 3 electrons, because they have to balance out to 0. So 1, 2, 3 electrons. So 3 of those. All right. And in this case, this atom of lithium has 4 neutrons, because we count up the grays, 1, 2, 3, 4. So we've got 4 in the nucleus right there. Well, what is this number? 6.94. It might make sense if it were 7, because 1, 2, 3, 4, 5, 6, 7, 3 plus 4 is 7. But this number is the total number of particles in the nucleus. Okay, well, wait a second. 1, 2, 3, 4, 5, 6, 7. Why does that not say 7 instead of 6.94? It's almost like saying there's 6 and 94% of a neutron in the nucleus. How can that be? Well, that can't be. But it's because this is an average right here. We say in the nucleus of lithium atoms, on average, there's 6.94 particles there. Now, in this one, there's 7 particles. But on average, there's slightly less than that. It's like saying that the average number of children in a household in America is 2.5. Well, you can't have a half of a child, but on average, it averages out to a half of a child right there. Similar to this right here. So, how many neutrons are supposed to be in an atom of a certain type? Well, that number that we just looked at, 6.94, is very, very close to 7. And that means that in almost every single nucleus of lithium, there are, in fact, 7 particles. 3 protons, because there has to be, right? Because otherwise it wouldn't be lithium. And then 1, 2, 3, 4 neutrons. But some of them have a little bit less. And so that brings that percentage down. So that percentage drops just ever so slightly if we have a large number of lithium atoms, because the number of neutrons actually varies a little bit. Let's look at it this way. We have 100 atoms right here, or 100 nuclei of atoms. But there's actually 6 of them that have less than 7 particles. For example, this one right here, it's got 7, right? It's got 4 grays and 3 reds. But there's 6 in here that have only 3 grays and 3 reds, for a total of 6. Which ones are they? It's kind of hard to see, isn't it? Well, how about if we do this? Ah, there we go. There, it's a little bit easier. So we can see that this one has only 6 particles, 3 red, 3 gray. This one, this one, this one, this one, and this one as well. So, if we count just neutrons, that is the gray ones right here, we've got 94 atoms with 4 neutrons, right? All these ones that are kind of faded out, they all have 4 neutrons. But there's 6 of them that have 3 neutrons. So what happens if we take 94 times 4 plus 6 times 3 and divide that by the whole number of atoms right there? That means that comes out to, if I have my right color right here, 3.94. So we've shown right here that each atom has almost 4, but these 6 atoms right here kind of drop down the percentage a little bit. That almost every atom has 4 neutrons. All right, that's that number right there. But some bring the average down to 3.94. So if you add 3.94 to the number of protons, that is the red ones, it gives you 6.94, which is the number that we looked at. All right, that 6.94 is a total number of particles inside the nucleus of an atom. If that's a little confusing, that's okay. We're not going to dwell on that too much, but I just want you to know where that comes from. So let's look a little more closely at this. This number right here is the atomic number of protons. And lithium will always have 3. This number is called the atomic mass. And it's a number of protons and neutrons. Oh, made my U kind of a little bit big. Trons. And it's an average because the number of neutrons varies a little bit. That can vary. This cannot. This always has to be 3 for lithium, and if it's a different number, it's got to be something else. But this can vary. It varies to the point where it's ever so slightly less than a whole number. But if we round up, we can expect that most atoms of lithium will have 7 particles, 3 protons and 4 neutrons. Okay, so in any naturally occurring atom of any certain type, there are the same number of protons and electrons. For example, there was 3 protons and 3 electrons in naturally occurring lithium. All the pluses and minuses cancel out, of course, to 0. And of course, since neutrons don't add any charge, they don't change it at all. So a naturally occurring atom of anything is going to be what we call electrically neutral. No positive, no minus. It balances out to being neutral.